Now, for more complex circuits, you can't always use reduction. If there's more than one EMF source, in fact, if EMF sources are in parallel, then you've got some issues that you can't really reduce. However, we can use the powerful rules of Kirchhoff, also called Kirchhoffs laws. And they can solve anything. Usually takes a little bit more time because we're going to be solving simultaneous equations. Believe it or not, we've actually already used Kirchhoff's laws as some of the logic that we've applied to circuit reduction. But let's go ahead and talk about the laws, and then we'll give an example so you can see how they're used. There are two of Kirchhoff's laws. The first one is called the junction rule. And first, we've got to understand what a junction actually is. A junction is anywhere that there is a fork in the road. Like here's a junction right there. It's also called a node sometimes. So the junction rule is simply this, that the current in the junction, any current that's going into a junction or node, is got to sum to the current going out of the junction or node. Water is uncompressible. So are electrons. Whatever goes in is got to come out. You can't start collecting electrons in any part of a wire. Otherwise, it'll become electrostatically charged. So let's use this as an example. Let's say I've identified that current 1 is going that way, current 3 is going that way, current 2 is going that way. What equation can I write using Kirchhoff's junction rule, or it's the junction law? Let's check it out. Well, seeing that I is assumed to be going in, and by the way, even if I1 doesn't go in, it'll just come out negative when we solve our equation. So it's okay to assume any direction of current. You should do it logically, but if you're wrong, the value will just come out negative. I1 is going in, I3 is going in, and I2 is going out. So what can we write based on this junction rule? Well, we know that I1 plus I3, what do they have to add up to? I2. This is the current going in right here. This is the current going out. Again, if you've guessed the wrong directions for these, that's okay. These values, whatever you guess wrong, will just come out negative. Okay, that's the junction rule. The sum of the currents in equals the sum of the currents out. No problem.